Okay, maybe can you just close the window there for the noise? I've put the aircon on, so that should be fine. Okay, this is a lesson about debugging, error tracing, and problem solving. This is something that's throughout, both offices. This is quite a problem where people, as soon as they encounter an error or they encounter a fault, they just sort of, they just sit there and look at the screen. Or they ask somebody next to them to sort of tell them where the problem is. But what this lesson is about is telling you how you can fix the problem and how you can actually go and find out where the problem actually is, and also obviously where it should be fixed. Because knowing where the problem is doesn't actually tell you how to fix it. That's two separate things. Okay. But before we go into this, I'm just going to tell you a quick story about an online shop. Okay. So there's this online shop. They had a nice web page and stuff with nice product lists where you can click to buy something, add to your shopping cart, pay with your credit card, fill in your address details, and they'll deliver it to your doorstep. So what happened is somebody logged in, they used a different browser, a browser that not everybody uses, let's say Opera. And on Opera there was a bit of a rendering problem where the buttons was actually a background image, and on top of the buttons they basically built the site to have sort of a transparency area that captures the mouse clicks. And these transparency areas in Opera didn't align with the buttons, they actually fell below the buttons there. You see those little dotted lines. So what happened is this user came in and he wants that product. He wants product number 1 or number 2. Okay. So he said, no, he wants product number 2. So what happens is he clicks on the buy button. Well, he clicks a little high, and without him knowing, he actually clicks this invisible transparent area, which is actually product 1. With the products being very similar, with a very similar price, he didn't notice. He carried on, he checked out, he filled in his address, he paid with his credit card. Obviously this order goes from here to the actual shop, to admin, to the warehouse, gets dispatched to the courier, which is a separate company. The courier drives the guy's address and gives them package. The guy opens the package and was like, but this is not the right product. So what does the guy do? He immediately starts screaming at the delivery guy. And he gives that delivery guy a piece of his mind. Tells him how incompetent he is and how he can't do his job and how he can't read what's actually the right order. But does that fix the problem? Is that where the problem actually was? Okay, so, and that's what we refer to as an upstream problem. So whenever we talk about the word upstream, it means going back. You need to go back in the process. Yes, basically if you would, let's say there was an error message in this example. The error message was the client screaming. That was the error message. It was the client screaming. He's like, no, there's an error here, there's a mistake. Okay. It doesn't help you fix it there, because you can't fix it there, because that's not where the problem is. You have to go back. You have to backtrace. Now you have to go to the delivery guy. Where did the delivery guy come from? You go to his depot. Cool. You have to check the order there. What does the depot say the order is? Then you have to go from the in the depot. You might actually get a document, see the order is actually right there. Whatever the delivery guy delivered is actually at the depot. It's the same order. So there was not a mistake there. So what do you have to do now? You have to go back again. See that this thing's recording? Yes. You have to go back again. Now you have to go to the warehouse, which is not the delivery company anymore. This is the actual warehouse, but they store these things. So you get the documents from the warehouse, which is another debug message, or a system.out or println, or another alert. Just to get information, to see what is on this document. This document saying, oh, it's also exactly what the guy delivered, it is as that's what the warehouse should have given the delivery team. So the problem is not there. Then you still have to go back more to the administration of the company that has this website. You have to go to them, check their documents. You see there's no problem there. You have to go back further to the website's database. And on the database you'll see, oh, it's still the same in the database. So the mistake that was made was actually right in the beginning. It wasn't right at the end where we all thought it was, or where the client thought it was. But now obviously fixing it is a bit difficult, because the client can tell you he clicked on this button, he clicked on the right product because he double checked. But the development company might say no. You had to click on the wrong one. I mean, the system won't make a mistake like that. So the problem is going to be that the development company, that let's say they say, okay, there's a possibility that there's a bug in the website, that the wrong product was delivered, okay, or the website somehow captures the wrong product. How is the development company going to fix it? The only way they can fix it is by replicating the exact scenarios that took place. And that's the first thing we're working with, is replication. How do you replicate the exact same circumstances that caused this error or problem? You have to replicate it first. So then they're going to have to go into their logs and they can probably see, oh, the guy used Opera instead of, let's say, Chrome or Firefox. I'm not even going to go into Edge or Internet Explorer because nobody uses that. So they can actually see, oh, okay, let's load up Opera. Let's open the site. And maybe then they can see that, oh, if they click a button, the button doesn't work. But if they click a bit lower, it works. Ah, there's the problem. That's where the problem needs to be fixed. So the problem where a client got the incorrect package is actually an HTML problem in the website. It's not even a logistics problem. It's not a Java problem or a database problem or an admin problem or a paperwork problem or a human error. It's none of those. It's actually HTML code that was just a little bit done incorrectly. Okay, it wasn't compatible with all the browsers. So, that's what I mean when I say upstream. You have to go back. And you have to debug as you go. So as you go back, you print out information. But obviously before you do this, you have to be able to replicate everything perfectly to get the same error message or the same problem that was found. Obviously there's two scenarios here. One is where you got a task assigned to you that is a problem. So you got a task assigned to you that say, this is a bug, it's a feedback task, this is buggy, fix it. That's the one scenario. And then you need to replicate it. That's where replication is important. Your replication is not important as obviously if you are busy developing and while you're developing, you're getting an error. Because then you've already replicated it. You found it and you replicated it at the same time. Then you can obviously just debug from there. So one of the key factors in debugging is collecting information. You need to collect as much information as you can. And this mainly goes with information going upstream, up the code. So you reverse execute the code, basically. And if it's on a live environment, then you can look at logs. There's always logs, somewhere there's logs. You need to find out where these logs are. In our system, you get stub calls, obviously, that takes place. And in the stub calls, it actually prints out all the information that goes from the back end to the front end. It actually prints it out for you. So there's already a lot of debugs in place. So actually go and look at them. See if you can find the exact stub call. Look at the information in there. A lot of you guys don't even consider even doing that. If you look at the information in there, you'll see, oh, well, all these fields are blank. That'll tell you something. Sort of gives you an idea of where it comes from, where the actual problem started. Because at the end of the day, this you'll find is very true. If there's broken data, it's going to cause broken code, which is going to give you an error message. And what a lot of people do is they go to the error message, and the error message say, oh, the problem is there. And they go there, and they say there's a null point exception there. They just put an if not null around it. That's not fixing the problem. The problem is that it never should have been null in the first place. So you have to ask the question, why is it null? So seeing the code as broken is not necessarily the right thing. Maybe you need to look at the data. Why is it null? It shouldn't be null. So go back. Go to your back-end process where maybe the data was coming from. If your back-end process throws the error and it was coming from the front end, go back to the front end. If in the front end and you still debug it then it's wrong, go back to your JavaScript. If it's there wrong, go back to HTML. Find where everything began. Go back to there. Because usually broken data will cause broken code, which will cause an error message. 90% of your problems you'll see will fall into this category. There obviously is some problems where there's actually an error in the code and there's a formula error and you'll get an error message at that exact point. But mostly if there's an error message, it actually comes from broken data. The broken data is caused by code somewhere else. It might not even be your code, it might be somebody else's code that actually breaks. Yesterday we had a case where we added something new, added a new left join, and suddenly we got an error. But our left join was perfect. But actually the error was that somebody else did a select long ago, but the hash field they selected was ambiguous. So that person had to put the table name dot the field name. But because he didn't do it back then, now suddenly this column exists twice. So now his code breaks. So you need to keep that in mind. It might not be your code even that breaks. You can only find that out obviously if you go upstream. So you can look at existing data. Then, obviously like I say, look at the actual error message. Some of the people never actually look at the message. They just see, oh, there's an error. But they've actually read what the error tells you. This error will, a lot of times, tell you exactly what the problem is. Read the error message in detail. If you're not sure what it means, Google it. Go to the documentation and see if there's some way you can figure out exactly what this message means. That's why there is error messages, is for you as coders to be able to actually go and fix that error using the information in the error message. Okay. Obviously, as I say, test different browsers. That's a very important thing. Sometimes the problem is only found in one browser, not all of them. But that's sort of, let's say 20% of the cases, that's the problem. So it's not often, but it is actually something that can happen. Then, you can actually insert debug messages everywhere upstream. So if all these things, different browsers will also give you different error messages. So let me go back. If you get an error message, a JavaScript message, use another browser as well, and you'll see that the message it actually gives you is completely different. But if you use those two messages together, it'll sort of point you actually to the right problem. You actually get more information that way. So that's also another way. That's also why you have to use different browsers, especially when it comes to JavaScript messages specifically, because you will get different messages. Okay, obviously, then upstream, from where the error occurs upstream, you can actually insert and print out the data that goes along with the code. Because basically what code is data gets passed from here to this line of code, to this line of code, to this line of code. As it goes down, it's actually data being passed from one instruction to the next. And if you want to find a problem, you need to know what the data is that was passed from one instruction to the next. So that's why you can go and you can put in system out print lines in your code. Or in our system, obviously you actually use dev.debug, because that'll print it out nice and red. And if it's online, it won't print it out, so your online log will be not too full of garbage. So obviously don't use that one, use this one. But in any project, whether it's here or not, you can use system out print and you can print out anything. If it's something like a hash map on an array list, an array, then you can't use this. Then you need to wrap it with the arrays.toString. You just wrap the array with that and print out the contents of the array. Otherwise, you'll get like a number at array or something like that. It won't actually give you the data inside the array. But all the data you can print out, whether it's a hash map, longs, ints, strings, floats, doubles, array lists, arrays, anything you can actually print out. You can print it out to the console, you can look what's in there. And that'll tell you where the problem is. If you just actually look at the data. And then the second one is, or the third one is especially non-strict languages like JavaScript. It's for all scripting languages. It's the same with PHP, Python, JavaScript, the other one, the AS one, the Microsoft one, ActionScript. No, ActionScript is Flash. The Flash is actually the same. Languages we don't compile the code. There you need to check for your variable names. If you do typo in a variable name, your editor is not going to throw an error. It actually will work. Your editor will work. If it throws an error, it will allow you to continue. So you need to check the exact spelling and case errors. Maybe there's an uppercase where there shouldn't be an uppercase. Maybe there should be an underscore. So you need to check those things. Sometimes the mistake is so small, even if you look at it carefully, you won't see it. So you really have to focus on that variable name and see that it is spelled correctly. If you use an A instead of an O, or a lowercase L instead of an uppercase I, you won't see it. You have to actually look at it very carefully before you see it. Obviously IDs as well. Check for IDs, same thing. The names and the case mistakes. In JavaScript, putting this dot in front of a variable name has a completely different meaning. It puts the variable in a separate place. Whereas in Java, it sort of fixes it by itself. In Java, if you just use a variable and it's a class variable, it'll work. It won't give you an error. But with JavaScript, using a variable, let's say called test, and you put this dot in front of it where you use it, it'll be a different variable than just using the variable test, and not this dot test. So just check for those mistakes as well. Okay, if all of this does not fix your problem, you still have a problem, especially when it comes to the logic of the code. A fourth approach can be is to comment out sections in the code to see if you still get an error. It's sort of a way to narrow down which code actually produces the error. This is especially true when there's loops. If you have something that, let's say, loop 1,000,000 times, you can't print out debug in the loop because you're going to sit with 1,000,000 logs and you can't look through those logs. Then you might think, okay, let's comment out half the loop, so just a certain part of the loop executes, and then see if we can somehow get the error. Or maybe you can still do the alerts and the debugs, but you just say, just put if in the loop. If the loop is smaller than 10, then print it out. So you only get the first 10 or something like that. Try and find out at which iteration the loop breaks. Okay. This is called wolf fencing as well. Basically, that comes from, it was also invented, I think, in 1970, around about there, where it was a way to find bugs in code, but this was obviously long ago when they were still using binary code and assembler and stuff like that. Where they would, it's basically it's about if you want to find a wolf in Alaska. There's one wolf in the whole of Alaska and you want to find this wolf. How do you find it? Because it only howls once at night. But once you go there, then it's gone. So the whole idea was that you take Alaska and you build a fence down the middle. So you separate it into two parts. And you sit on the fence at night and you hear which side it howls. So if it howls on this side, then on this side you build another fence through that half. And you go and sit on that fence and you hear on which side it howls then. And you just keep on doing it until you find the wolf. Okay, that's where it comes from. So you can do the same with code. You can actually take a block of code, you can see if you can comment on half of it. See if it still works. If it gets an error, then obviously the half that's not commented out has the error. And you can maybe see if you can half that as well. Run it again, so you still get an error. If you don't get the error, then it's obviously the quarter that you commented out. And then there you can remove half the comments there. And that way you can narrow down to the exact code that caused the error. And basically it's like binary searching. And as you know, binary searching, with a few iterations, you can get to an answer really quickly. So let's say it's 1,000 lines of code. 1,000 lines of code and somewhere there's a bug. You can actually, by halving it and halving it and halving it, you only have to halve it 10 times and you will get to 1 line of code. Because it's binary search, because it works in an exponential fashion. Okay. And lastly, you can actually hard code data. So let's say the data comes from the database and, I don't know, for some reason, you don't have the same data as online, but you can't copy it here because of too many relationships and problems. You can actually hard code the data. So wherever the method returns data, or an F-bomb or whatever, you can just construct a new one and put data in there, hard code in your code, to try and break it. Because that actually goes with the replication. If you struggle to replicate it, sometimes you need to do that. Just to force it to break. But, obviously very important, but number 4 and number 5, you should always have to remember to remove this once you are done. Don't leave the code commented out or hard code data in. Because then once it gets to the online environment, it's going to break again. Okay. Cool. And I just here I want to show an example of sort of just going through everything we've learned. So basically what happened here is that there was an error thrown there. Let's call it a null pointer exception. Was thrown at that line there. So what you have to do is actually go upstream. There's rare occasions where you have to go downstream, but that's very rare. Most of the times you have to go upstream. So let's go upstream. So we go up, up, up. Let's say this is a method, so we go up the lines of the method, and we just check every line. We just sort of scan it, and see if it might cause a null pointer there. And then we see, no, it doesn't look like it. So maybe what we can do is we can put debug messages in there, system out print lines or alerts. Obviously this is Java, so we're going to put our system out print line. Obviously in our system we would use this one, we have the debug. So you can put those debugs in, you can put it between every second line. So then you know exactly what happens after each line, if you want to. Or you can put in one debug, it's up to you. Maybe you get to the top of the method. So at the top of the method, the data you get there is already wrong. So you know that it can't be in this method that something went wrong, because the data you get in the method is already wrong. So you have to make a choice. Are you going to go further upstream, or did you find the problem? But let's say in this scenario, we had to go further upstream because we haven't found the problem yet. So now you need to figure out, how did this method get called? From where does it come from? Where is upstream? You need to ask yourself the question. Sometimes it's not as straightforward. Sometimes you need to dig to find out what called this method. So in this case, let's say it was a stub call from the front end. So what you can do now, you see, is there logs there? Lots of the times when you go from one section to a system to the next, there's log files. You're going to find log files. So go look at these log files. Then you don't have to do debug. Maybe the log file will tell you what's wrong. And in this case, yes, we do have log files. Our stub calls all get logged. It's in your console. You can debug it here or here. It gets printed into both log files, in your back-end process as well as in your front-end process. The back-end process might be state static. Your front-end process might be web-based. But it will print at both sides. Sometimes what you can also do is print out both. Check the logs there and there. Check if the logs matches. If the logs doesn't match, then the problem is actually this transaction over here. Then it means your F-bomb or your Java bean or your method of pushing data from here to here, that method is broken. So then it means your F-bomb, your to stream and your from stream, something's not right, they're not aligning. The data doesn't go through. Now you get, you put a debug in there, you see, oh, information's still wrong. You can go up, 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 it's still wrong. You can put in debugs there. Now there's another method called. Now you have to figure out, where does that method get called? And you might see, oh, it actually gets called from JavaScript through an AJAX call or a W call, like we call it. And you can also, in there, because it's JavaScript, obviously now you can use alert, or in our system you can use wdebug, which will automatically go inside objects and debug everything. And you can put in debugs on every line if you want to. You can even go further up, and then you see, oh, even there the data is wrong. Obviously, if the data there was right, it means that the problem is here somewhere. But because the data is wrong, we need to go further upstream. then we see, okay, where does this method get called? Oh, it actually gets called in HTML. It's onClick. So in the onClick, we call that method. And oh, I see in the onClick, we didn't actually put, there was 2 parameters. There was supposed to be 2 parameters in the function call, but we only supplied 1. Ah, that's where the problem is. So what you just add an extra parameter in your onClick. But your error message was, yeah, in your backend. In static, you've got a no-point exception. But the actual problem was, yeah, you see. So yeah, if you go through these steps and you approach it like that, you will find your problem. And then it will tell you how to fix the problem as well. Because you know where it actually originates from. So at the end of the day, if you debug properly, you will know how to solve the problem. Even though debugging and solving is 2 separate problems, or 2 separate practices, finding the problem and solving it. But if you do your debugging right, it will tell you exactly how to fix the problem. Okay, does anybody have any questions? Nothing? Does everybody understand this? Cool. Okay. Yeah. So welcome to debugging, and hope you can fix your problems quicker.
Stop recording about 10 minutes ago, but you were busy talking, so